So today we're starting our unit on quadratics, and the first objective of that is to write a quadratic in standard form, and then we're going to learn how to use the discriminant to find the number of solutions that a quadratic has. So here we have, this is a key point, our main point from the video, is that this is our standard form. Standard form of a quadratic. So this is comparable to slope-intercept form. We already know that slope-intercept form was y equals mx plus b, and that was our standard form. For a linear function. And now we have something new, right? Our quadratic equation, which is y equals ax squared plus bx plus c. There are a few important things we need to know about our standard form of a quadratic. First of all, a, b, and c are coefficients. So these will be numbers, just like in our slope-intercept form, m and b were numbers. Right? And then our variables are still going to be y, and here we have an x squared and an x, right? And in our linear function, we had y and x. Now that is the big difference between linear functions and quadratic functions, is the exponent. So here, anytime we see an x squared at all, if x squared is the highest exponent, then it is a quadratic. Right? And the reason that we have linear functions, because we have x and it only has the variable of 1, and that's what makes it linear. Right? So we're going to add that to our key points. Key points. An equation with the highest exponent being 2 is a quadratic. Okay? So this is really important. That's how we know something is a quadratic or not, is when we see this x squared. Now, obviously there's going to be variations. We didn't always get something in slope-intercept form, and that's going to be the same for quadratics. So when we originally learned, we would see things like 2x plus 5. But then we realized that it's okay. Maybe we don't have a b, and it's okay to see an equation like y equals just 2x. Or sometimes we had no slope, so we would see an equation like y equals 5. And we have all these different variations. The same thing can happen in our quadratic formula. We want to have y equals ax squared plus bx plus c. Our standard form says that the highest exponent goes first, then the lowest exponent, and then the number that has no exponent at all, which we just call a constant. So we might see something like y equals x squared plus 10x minus 4. That's our basic equation of a quadratic. But quadratics can be missing pieces, just like we had in slope-intercept form. But in order for it to truly be a quadratic, we always have to have the x squared. So if it's missing the x squared, then it's not a quadratic. But maybe we're missing the bx. That's okay. I can have x squared minus 4, and it's still a quadratic. Or I can have something like y equals x squared plus 7x. It's still a quadratic. So not all of the pieces have to be there all the time, but the important part that makes it a quadratic is the x squared is there, the x squared is there, the x squared is there. So we have to have our x squareds in order for it to be a quadratic, and that's our key point. When the highest exponent is 2, it is a quadratic. So if we had an x to the third, now it's something else. The highest exponent here is our squared x, and that's what we're looking for. So now let's make sure we can write this in standard form. We're not always going to get it in standard form. That would be too perfect of a world. So we need to know how to rearrange it. It's going to be very similar to what we did when we first learned how to rearrange our slope-intercept form. So if it helps, we can divide our equation by putting a line through the sign. And over here I'm going to write my general version of the standard form as a reminder. My y is equal to ax squared, then my bx, and last my constant. So I want to keep my y all by itself, and everything else needs to move to the other side. So right now y is in the right place, so I need to move my 4x squared and my 6x. So I can move 4x squared by subtracting it to the other side. That gets rid of it on the left, so I have y plus 6x equals, and I'm going to put the x squared in front because I know standard form has to have the x squared go first. So I have a negative 4x squared, and then 17 is going to be a plus 17. And again, my y is on the right side, but I need to get rid of my 6x, so I can subtract 6x and subtract 6x. So that eliminates there, and I have y is equal to, my x squared term needs to go first, then my x term minus 6x, and last, my number without a variable or my constant. And I have written an equation in standard form. So it's the same thing that we've been doing. Now we're just adding this extra term, this 4x squared, which we weren't seeing when we were doing slope-intercept form. So another example, sometimes there's more stuff moved around and maybe we have to do some extra work. So it might not be as easy as just shifting things over. So again, I want to draw my line through my sign. And to be helpful, I can write my equation, my standard form, off to the side as a reminder. So again, I want to get my y by itself, and I notice that y is on the wrong side. So I'm going to have to, first of all, get my y over to the other side. So if I'm going to write this in steps, I'm going to make step 1, get y on the left. So I can move my y over by subtracting the y to both sides. So that eliminates. Now I have y minus 2x plus 3x squared equals 9x squared. Okay. And once I move my y over, my second step is to collect like terms. Collect like terms. On the right. So in the last example, I didn't have any like terms. All I had to do was move things over. But if we look here, I know that I need to move my 3x squared to the other side. But I also have a 9x squared already waiting for me over there. So I want to make sure that, yes, I'm moving it over, but that I'm also combining my like terms. So in order to get rid of my 3x squared, I'm going to subtract 3x squared and subtract 3x squared. So that's going to eliminate on the left-hand side, which leaves me with y minus 2x is equal to, and now I can combine my like terms. My 9x squared and my 3x squared have the same variable parts, so 9 minus 3 gives me 6x squared. And then I still want to be moving my x term over to the other side. So in order to get rid of a negative 2x, I'm going to add 2x to both sides. So that will eliminate on the left side, which leaves me with y equals my 6x squared term goes first, my 2x goes second. Right? And looking at my standard form, I should have a plus c, but this problem didn't have any constants, so there's just nothing for me to add. It's like I have a plus 0, but that's not really necessary for you to write that, so if you'd prefer to just leave it, and that is your quadratic being rewritten. So here we have our first self-check. Go ahead and try to write the following example in standard form following the steps. Get your y by itself, move everything over to the other side, and make sure you're checking for like terms. You can pause the video, and we'll come back in a second with the answer. Alright, and this is the answer that you should have gotten. So if you are incorrect, go back and check the common errors. Right, which are not using the correct inverse operation. So if we see a negative 2 here, we need to add 2 to the other side, which is going to make it positive. So make sure you're using the correct inverse operation. Right, and also go back and check your like terms. Make sure you didn't accidentally add an x instead of an x squared. Make sure you weren't combining all of the x's, that you were only combining like terms. So x squareds with x squareds and x's with x's and so on. You don't want to accidentally combine things. And then just go back and double check your math. Sometimes we accidentally press the wrong button on the calculator and we get a funny answer. So common errors here, but this should be the answer. So if you didn't get this answer, make sure you mark it in your notes so that you can ask questions when you get back to class. So moving on, once we know how to rewrite our equations, our quadratics in standard form, we can do a lot of things with that, and those are all going to follow. But one other thing that we can do with our quadratic forms is find how many solutions they have. And this is the important formula that we need to use. This is called the discriminant. Discriminant. There we go. Alright, so this is a key point. You need to know this formula. The B, the A, and the C are all going to be pulled. Right, B, A, and C are pulled from our standard form, from our ax squared plus bx plus c. So we're going to be using the number in front of the x squared, the number in front of the the number in front of the x, and then that number that's just all by itself. And we're going to be substituting in for our b and squaring it, in for our a, and in for our c. So we need to get our equations simplified and written correctly in standard form first, so that we know that we're taking the right a, the right b, and the right c to find our discriminant. So let's do an example and see what that looks like. So example number 3, they want us to find the number of solutions for the quadratic given here. So first of all, we need to identify what our A, our B, and our C. All right, so step 1 would be get it into standard form. All right, so is this equation in standard form? Yes, we have the x squared term, then the x term, and then the constant. So we're good to go. Step 2, find your A, B, and C. So I know that my A is an invisible number, but I know it's there. It's a 1. My B is a -8, and my C is a 15. So once I have found and identified my A, B, and C, step 3 is substitute. Substitute in 2b squared minus 4ac. So here we go. I have my b squared minus 4ac, the formula for the discriminant. So I'm going to substitute -8 squared minus 4 times my a is 1 and my c is 15. And so we need to remember to use order of operations. So what goes first in my order of operations? Well, I need to do exponents first. So a negative times a negative is going to be a positive 64. Make sure we're using our parentheses in our calculators. All right, this is a common error. Use parentheses. In your calculator. If we forget our parentheses, we might end up getting a sign error. Certain calculators don't recognize that the squared is going on the negative. So a -8 times a -8 is 64. And then we have -4 times 1, which is 4. And then 4 times 15, which is 60. So minus 60. So 64 minus 60, and I get the number 4. Now, all I'm looking for on this number is it positive, is it negative, or is it 0? All right? I don't care what number I get. All right? So here's another key point. The number doesn't matter. This isn't saying we're getting 4 solutions. The number doesn't matter. Okay. All we want to check is your answer positive, negative, or 0? So we got a 4. Is our answer positive, negative, or 0? Well, our answer is positive. So that means we have 2 real solutions. 2 real solutions. All right, so all we're doing is we plug in our A, B, and our C, we solve, and we look to see what the sign of our answer is, and that's going to tell us we have 2 solutions. We're going to talk later about how to find those solutions, but for right now, all we're worried about is how many are there. And we found that a positive number means 2. Let's look at another example. Find the number of solutions for x squared minus 8x plus 16. So first we need to identify, is it in standard form? Yes, it's already in standard form. So number 2, we need to find our A, our B, and our C. My A, again, is an imaginary 1. My B is a -8. My C is a 16. So now I want to finally substitute my values into b squared minus 4ac. So I plug it in. My B is -8 minus 4 times A is 1 and C is 16. So now I simplify. Oop, I forgot the squared. -8 times -8 is positive 64. 4 times 1 is 4 times 16. 4 times 16 is, I bring down my negative, and I have a 64. So now I have 64 minus 64. My answer is 0. So again, we want to be asking ourselves, is the answer positive, negative, or 0? Right? And here, we found a 0, so this means something else. And again, this is a key point, that when you find the discriminant, if your answer is 0, right, then you only have one solution. One solution. So a positive number is going to give us 2. 0 gives us only one solution. Let's look at one more example. It's in standard form. I identify my A, my B, and my C. A is an imaginary 1, B is a negative 8, and C is 17. I substitute the values into the formula of the discriminant. B squared, I'm going to have negative 8 squared minus 4 times 1 times 17. So 8 negative times a negative is going to give me 64. 4 times 1 is going to give me 4 times 17, which gives me 68. 64 minus 68 gives me a negative 4. So again, I should be asking myself, does my answer give me a positive, a negative, or a 0? And finally, we get the last case. All right, a key point. If a negative answer then you have no real solutions. No real solution. Right? So we went through all possible cases. Right? When we have a quadratic, we have the possibility of having at least 2 solutions. But we might get one, and we might get none, which is the same thing we had when we had our regular linear equations. When we were solving things for x, we have an exponent of 1. We have the chance of getting one solution, so just x equals, or sometimes we get no solution. So at most, you could have one solution. When we have an x squared, at most we can have 2, but we can have 1 or none as well. So let's make this a big key point. All right? If b squared minus 4ac is greater than 0, meaning it's positive, then that means we have two real solutions. And if on your paper you're just writing 2 solutions, that's totally acceptable. If my b squared minus 4ac is equal to 0, meaning that it comes out and we just get 0, then that means we have one real solution, or one solution. And the last example is if we have b squared minus 4ac and it's less than 0, which means it is a negative number, then we have no real solutions. So this is a really important table because you're going to need to know all three cases. Not only are you going to have to know how to find the discriminant, so you need to write discriminant along the side. You need to know how to find the discriminant using this formula, substituting your values in, and getting an answer. But you also need to know what that answer means. So what positive means in terms of solutions, what negative means in terms of solutions. And that's really going to help you check your work later on. So here we have two self-check problems, self-check 2 and self-check 3. You should have already done the first one and checked your work. For self-check 2 and self-check 3, you're going to do it in your notes, and we will check it tomorrow in the Do Now. So make sure that you have all of your work completed. If these are not completed, you will be receiving a LaSalle.